In my last video on permutations and combinations, we have studied about combination and combination formula. In this video, we are going to study how to use combination formula to solve word problems on combination. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. How many cards can be drawn through 21 points n equals 21 on a circle? For drawing a card of a circle, we need 2 points on the circle, say A and B. When we draw the card, whether we join point A to point B or point B to point A does not matter because the card is going to be the same. So this is a case of combination. And since we are drawing a chord by joining 2 points, R is 2. So the number of chords in this case will be 21C2, 21 factorial upon 21 minus 2, 19 factorial into 2 factorial, 21 into 20 into 19 factorial upon 19 factorial into 2 factorial 2. Cancelling 19 factorial, 2 ones are, 2 tens are, the number of chords will be 210. In how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? When we select 3 boys from 5 boys and 3 girls from 4 girls, we have to do this selection simultaneously. That is at the same time. So here we have to use multiplication. So the number of ways these teams can be formed will be 3 boys from 5 boys multiplied by 3 girls from 4 girls. Note the use of multiplication sign here, equals 5 factorial upon 5 minus 3 factorial, 2 factorial into 3 factorial, multiplied by 4 factorial into 4 minus 3 factorial, 1 factorial which is 1, multiplied by 3 factorial. This will be 5 into 4 into 3 factorial upon 2 factorial which is 2, multiplied by 3 factorial, multiplied by 4 into 3 factorial upon 3 factorial. Cancelling 3 factorial, 2 ones are, 2 twos are, we get 40 such selections. What is the number of ways of choosing 4 cards from a pack of 52 playing cards? In how many ways 4 cards are of the same suit? We have 4 suits: diamond, club, spade and heart, and there are 13 cards belonging to each suit. Here selection of 4 cards from the same suit is independent of each other, so we have to use addition sign here. Number of ways will be 4 cards from 13 diamond cards plus 4 cards from 13 club cards plus 4 cards from 13 spade cards plus 4 cards from 13 heart cards. This will be 4 times 13C4, 4 into 13 factorial upon 13 minus 4, 9 factorial into 4 factorial, 4 into 13 into 12 into 11 into 10 into 9 factorial upon 9 factorial into 4 factorial, 4 into 3 into 2. Cancelling 9 factorial, cancelling 4 threes are 12, 2 ones are, 2 fives are 10. Total 2860 ways. In the same problem, what if the 4 cards belong to 4 different suits: diamond, club, spade and heart? Here selecting one card from each suit is happening simultaneously. Therefore, we have to use multiplication sign here. So number of ways these 4 cards from 4 different suits can be selected will be: one card from 13 diamond suit multiplied by one card from 13 club suit multiplied by one card from 13 spade suit multiplied by 1 card from 13 heart suit. This will be 13 multiplied by 13 multiplied by 13 multiplied by 13. 13 raised to 4. 28561 ways. What is the number of ways of choosing 4 cards from a pack of 52 playing cards? In how many ways 4 cards are of the same suit? We have 4 suits: diamond, club, spade and heart, and there are 13 cards belonging to each suit. Here selection of 4 cards from the same suit is independent of each other, so we have to use addition sign here. Number of ways will be 4 cards from 13 diamond cards plus 4 cards from 13 club cards plus 4 cards from 13 spade cards plus 4 cards from 13 heart cards. This will be 4 times 13c4, 4 into 13 factorial upon 13 minus 4, 9 factorial into 4 factorial, 4 into 13 into 12 into 11 into 10 into 9 factorial upon 9 factorial into 4 factorial, 4 into 3 into 2. Cancelling 9 factorial, cancelling 4 3s are 12, 2 1s are 2 5s are 10. Total 2860 ways. In the same problem, what if the cards are of same color? We know that there are 26 red cards and 26 black cards. So, selection of 4 cards from 26 red cards and selection of 4 cards from 26 black cards is happening independently. Therefore, here we have to use plus sign. So, the number of ways of selecting 4 cards of the same color will be 4 cards from 26 red cards plus 4 cards from 26 black cards. 2 times 26c4, 2 into 26 factorial upon 26 minus 4, 22 factorial into 4 factorial. 2 multiplied by 26 into 25 into 24 into 23 upon 4 factorial, 4 into 3 into 2. 4 3s are 12, 12 2s are 24, cancelling this 24 with this 24. Remaining calculation works out to be 29900. So 29,900 ways in which this can be done. Determine the number of 5 card combinations out of a deck of 52 cards if there is exactly one ace in each combination. There are 4 aces in a pack of 52 cards, and since there must be exactly one ace out of 4 aces can be selected in 4 C1 ways. We have to subtract these 4 aces from 52 cards, so we are left with 48 cards, and out of these 48 cards we have to choose remaining 5 minus 1 is, that is 4 cards out of 48 cards in 48 C4 ways. This one card and these 4 cards are selected simultaneously, so total number of ways in which this can be done will be 4C1 multiplied by 48C4, which is 4 multiplied by 48 factorial upon 44 factorial into 4 factorial, 4 multiplied by 48 multiplied by 47 multiplied by 46 multiplied by 45 upon 4 factorial, which is 4 into 3 into 2. 4 2s are 8, 8 6s are 48, 3 1s are 3 1s are 3 5s are, and this product works out to be 778320 ways. In how many ways can one select a cricket team of 11 players from 17 players in which only 5 players can bowl? If each cricket team of 11 must include exactly 4 bowlers, the team of 11 must contain exactly 4 bowlers. So these 4 bowlers can be selected from these 5 bowlers in 5 C4 ways, and after having selected 4 bowlers, remaining 7 players need to be selected from 17 minus 5, 12 players. And since this selection of bowlers and players is done simultaneously, we have to introduce a multiplication sign between them, which will be 5 factorial upon 1 factorial into 4 factorial multiplied by 12 factorial upon 5 factorial into 7 factorial. 5 multiplied by 12 into 11 into 10 into 9 into 8 upon 5 factorial. 5 into 4 into 3 into 2. 5 2s are 10 and 4 3s are 12. The remaining multiplication works out to be 3960. So these many number of ways this particular cricket team can be selected. How many words with or without meaning, each of two vowels and three consonants, can be formed from the letter of the word daughter? In the word daughter, there are three vowels A, U, and E, and two vowels. Out of these three vowels can be selected in three C2 ways. And after having selected these three vowels, we have to select three consonants out of these five consonants D, G, H, T, and R. And since we are doing this simultaneously, we have to introduce multiplication sign between them. So that gives us 3 multiplied by 5 into 4 into 3 upon 3 into 2. Cancelling these 3, 2 ones are, 2 twos are. We get 30 such words. But this is not all. These two vowels plus three consonants, that is 5 letters, can arrange between themselves in 5 factorial ways. So the total number of ways in which the required number of words can be made will be 5 factorial multiplied by this 30, 120 multiplied by 30, 3600 words. A committee of 7 has to be formed from 9 boys and 4 girls. In how many ways can this be done when the committee consists of number 1, exactly 3 girls? First we have to select 3 girls from 4 girls, and after having selected the girls, we have to select 7 minus 3, 4 boys from 9 boys, and since this is happening simultaneously, we have to introduce a multiplication sign between them. This will be 4 multiplied by 9 into 8 into 7 into 6, 4 factorial, 4 into 3 into 2. Cancelling 3 twos are 6 and 4 twos are 8. We get 504 such committees. Number 2. The committee consists of at least 3 girls. At least 3 girls means 3 girls and 4 boys, committee of 7, 4 girls and 3 boys, committee of 7 again. Committee of 3 girls and 4 boys can be formed in 3 girls from 4 girls multiplied by 4 boys from 9 boys, which will be 504 as above. Committee of 4 girls and 3 boys can be formed by selecting 4 girls from 4 girls multiplied by 7 minus 4, that is 3 boys from 9 boys. This will be 1 multiplied by 9 into 8 into 7 upon 3 into 2. 3 threes are 9, 2 fours are 8. This will be 84 committees. Number 3. The committee consists of at most 3 girls, that is 0 girls, 7 boys, 1 girl, 6 boys, 2 girls, 5 boys, or 3 girls, 4 boys. First type of committee can be formed 0 girls from 4 girls multiplied by 7 boys from 9 boys. This works out to be 36 committees. In the second type of committee, 1 girl from 4 girls multiplied by 6 boys from 9 boys. This will work out 504. In the third type of committee, 2 girls from 4 girls multiplied by 5 boys from 9 boys. This will be 756 committees. And the fourth type of committee will be 3 girls from 4 girls multiplied by 4 boys from 9 boys. That will work out to be 336 committees. So, total number of committees following this condition, there should be at most 3 girls in the committee will be addition of these 4 types of committees, 1632 committees. Here we are adding the number of committees because each type of committee can be formed independently. In an examination, a question paper consists of 12 questions divided into two parts, Part 1 and Part 2. Part 1 contains 5 questions and Part 2 7 questions respectively. A student is required to attempt 8 questions in all, selecting at least 3 questions from each part. In how many ways a student can select a question? At least 3 questions from each part suggests that first we have to select 3 questions from these 5 questions, and after having selected 3 questions the student can select 8 minus 3, that is 5 questions from the second part containing 7 questions. The student can also select 4 questions from the first part containing 5 questions and remaining 8 minus 4, that is 4 questions from the second part containing 7 questions. He also can select 5 questions from the first part containing 5 questions and 8 minus 5, that is 3 questions from the 7 questions of the second part. Let's again go back to the conditions given. At least 3 questions from each part. Now in this column we have selected 3 questions from first part. In this column 3 questions from the second part. Secondly, we have selected 4 questions from the first part and 4 questions from the second part. And thirdly, we have selected 5 questions from the first part and 5 questions from the second part. So the condition that at least 3 questions from each part is also satisfied. Okay, now we will evaluate each option individually. 5C3 is also 5C2 and 7C5 is also 7C2. According to this relationship, it will be 5 into 4 upon 2 multiplied by 7 into 6 upon 2. 2 2s are 4 and this is 210. The second option will be 5C4 is 5C1 multiplied by 7C4 is 7C3. It will be 5 multiplied by 7 into 6 into 5 upon 3 into 2, cancelling 6, it will be 175. In the third option, 5C5 is 1 multiplied by 7 into 6 into 5 upon 3 into 2, cancelling 6 with this 6, which is 35. Now these three options are happening independently. So we have to add 210, 175 and 35, which gives us 420 ways in which these 8 questions in all can be attempted. 420 ways. From a class of 25 students, 10 are to be chosen for an excursion party. There are 3 students who decide that either all of them will join or none will join. In how many ways can the excursion party be chosen? In the first case, when all 3 students decide to join, then remaining 10 minus 3, that is 7 students can be chosen amongst 25 minus 3, 22 students. 22 see 7 ways. And in second case, when none of the 3 will join the excursion, then all 10 students can be chosen from 25 minus 3, that is 22 students in 22 C10 ways. So the number of ways in which this excursion party be chosen will be 22 C7 plus 22 C10 ways. If you like this video, please like, share and subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.